So, everybody has your calculator. It's out. Turn it on. Everybody got their calculator powered on? Yes, Michael. Okay. Well, you'll have to watch the video at home and do it yourself. This will be on PowerSchool. So, all right. You're going to start by pressing the program button. Where's the program button located? Look at the screen. Right there. When you press the program button, your calculator screen should look like this. I want you to move over to the New tab, and where it says Create New, press Enter. So now your screen should look like this. You need to name your program. You can type in any name you want. I'm going to name mine Quad. You could name yours Hubert or whatever you want to name it. So pick a name for your program. So you'll notice above, like, everything has like a little A, B, C, etc. Just press that button and it'll start typing a letter. You don't need to even press the alpha to do it. Here it's automatically selected for alpha. Because this is the quadratic formula. It comes after the R. Or before the R. That's the letter, the way the alphabet works. Okay. Once you've got a name for your program, go ahead and press Enter, and your screen should now look like this. So the first thing that I'm going to ask this program to do is clear out everything else that's on the screen so it'll be easy to display things. So the command that I'm going to type here is called Clear Home. To do that, I'm going to press the program button again. That's going to open up a menu that looks like this. I'm going to tab over to the I/O tab. I/O. And then from that, I'm going to pick the Clear Home command. You'll press Enter, and then your screen should now look like this. Maybe. This Clear Home command is what we're looking for. Yes. When you do that, your screen should now look like this on my display. Okay? Anybody still looking? Okay. So go ahead and press Enter again to move yourself to the next line. You'll press the Program button again, move over to the I/O tab, and this time select the Prompt command, and then type in the letter A. To type in the letter A, you'll have to press alpha and the letter A. Correct? And then, correct. When you're done, your screen should look like this. So again, if you're like, did I do that right? Just check against my screen. If your screen looks the same, you're in good shape. You're now going to repeat that process 2 more times to where it says Prompt B and Prompt C. So make sure you press Enter to move to a new line. Then go back and press the Program button. You do have to write A, B, and C. So if you press the wrong button, just press second and then the Mode button, which is right next to it. Now press the Program button again. This time go over to Edit. Select the name of your program, and it'll be right where you left off.
I did that, and it just...
Because you picked metric,
Oh.
not quad.
Thank you. So if I want to get rid of that,
Please.
oh,
Press enter to go to the next line.
thank you.
Marshall, what's up? You have a different calculator. Yeah, I'm not positive where these commands are located on the TI-89. So, yeah. It is. All right. Marshall, at least for right now, my best suggestion to you would be I would go to YouTube and I would type in programming quadratic formula on TI-89 and press enter and see what you get. It's very likely somebody's got this on YouTube at some point. If you have trouble with it, come see me and we'll figure it out together. But that would be my first easiest suggestion in terms of like what to do because you have a different calculator than everybody else does. Is that okay? All right. Has everybody got prompt A, B, and C in? Okay. The next step is I'm going to type in the quadratic formula. So this, make sure that your next line looks exactly like this one. When you get this little arrow, how do you type in the arrow on your calculator? It's this STO button right here above the on. We don't have a plus or minus. Notice this is just a plus sign here. Guess what we're going to do in the next line? The exact same thing except the minus. What's that, Matthias? There's two lines now. Well, stand up and you can move closer if you need to. Oh, okay. So we need to press alpha and then see the little A there. Then it'll get you a second. So alpha and B, and then alpha and C.
And this is like the cell you have, and I have the cell.
Mm-hmm. Exactly.
This is second credit. I was in a different tab, and then
So just press the program button, and this time go to the edit tab, and pick that.
okay.
It is a D at the very end, yes. Yep, this button down here.
Why are there two parentheses on the right next to C? There's like one parenthesis.
Yep, one of the parentheses is for this one at the very beginning. The other is for the one at the square root. You absolutely need it to look identical to what I've typed here.
What's the unsecond one under the first? Under the first equation, what's that? The first. It's cut off the screen. No, below that. Oh,
It just depends. You press enter to go to a new line after you type the first one. Everywhere there's a colon is a new line. That's start of a new line. Notice there's not a start of a new line here. You just keep typing and it'll wrap it down to the next line. So don't press enter in between this parenthesis and this parenthesis. That's the division symbol. That's okay. You're not used to doing it because it's broken on your calculator. It's this button right here.
Wait, when we finish it, do we click enter?
We'll go to another line. We still have a few more things to do.
Click enter and then...
Yep. D is at the very end. Yes, that is the letter D. Again, those of you that didn't have your calculator with you today, make sure that when you do locate your calculator, you watch the video here and program this in on your own at home. I'll post to our Power School page both the video of me walking through this along with this PowerPoint. So again, if your calculator's memory gets cleared, I know some people have a class where their teacher routinely clears their calculator memory. You'll have to redo this on your own, but the video and PowerPoint will be up there so you can walk through it on your own. It goes much faster the second time or third time. Yes. Yes, because we still have a little bit more to do. So again, what we've done so far, the prompts, means that the calculator is going to ask for a value for A, B, and C. So we're going to type those in when we run the program. Then it's going to take the values for A, B, and C and perform the quadratic formula on them and store the values into the space D and E. What we need to have the calculator do now is to display those values for us. Are we ready to do the next step? Okay. All right. All right, Pokies. It's so what the STO command does is it stores a value in a variable. Yeah, so whatever the answer is, it's going to be stored in D, because we need to then ask the calculator to show us that answer later on. So it's going to ask us we're going to ask the calculator to display D, because that's where our answer is stored. So these need to be A, B, and C. So A, B, C. Am I not answering your question?
No, I'm just like, why I use this, I calculate this is X.
Ah, okay, so you don't want to use this button. So the green button is going to give us the green letters on that button. Is that? Okay. You're welcome. All right, next step. Next step. So you're going to, after you've typed in this last line, make sure you press Enter to move to a new line. We're going to press the Program button again, move over to the IO command, select the Output command, and type in output 6, 1, D. It's above the 7. So what the output command is doing is we're going to tell it a row and then a column to put our answer. So this says on the 6th row, in the first column, put the answer to D. Exactly. And then you repeat the process again for our other answer that we're going to display on row 7, column 1, and we're going to put our answer E right there. There's one more thing we needed to do. You should. All right, last step. We're going to press the Program button again, this time from the CTL menu. Go all the way down to the bottom and find the Stop command. And press Enter on Stop. So the last line should just be Stop. Once you've done that, you can exit out of the Program menu by pressing Second, and then the Mode button, which is right next to the second button. And that should bring you to the home screen. We'll do that in just a moment. Okay? So we're just going to wait for everybody to catch up and finish writing their program in. And then we'll talk about how to use this and interpret this and some modifications we might need to make to the settings on our calculator to make sure we're getting what we want out of this thing. Okay, anyone still typing their program? Very good. That. So what I'm going to do now is I'm going to open up and look at the assignment from last night. And we're going to use our program we just made to check some of these answers from what we were supposed to do last night. I will show you. All right. So, everybody got their homework from last time out here? So, on number 1, I guess I just forgot to type in the equals 0 part there, so you can write that in yourselves. My apologies on that. Let's check number 1 using our quadratic formula program that we just wrote. Sound good to you guys? And we'll compare it to the answer that we get manually. So, to access that program we just wrote, we're going to press the program button. And then under the execute tab, we're going to select the program name that we just wrote. And then press enter. Now for A in this problem, what's our value for A? 1. And our value for B? -9. Press the program button. And then -22. Hold on a second. Shh. Too many questions being shouted out. I didn't type the equal sign at all, or press alpha or any of those things. I pressed the program button, selected my program that we just wrote, and pressed enter. And the program outputted the A equals question mark, B equals question mark, C equals question mark. All I had to do was type in the number that I wanted for A, B, and C. If I press enter one more time, it outputs my 2 answers, which should have been positive 11 and negative 2. Did everybody's program work? If your program did not work, now is the time to say something so we can troubleshoot that. It did work. Yeah, that should be fine. As long as you have the two answers, I think it's okay. Is your cursor flashing on the screen somewhere? Yeah, that's... What did you get? Crazy decimals? Okay, so you're missing a parenthesis likely in your program. Is the likely issue. So my suspicion is after the b squared minus 4ac, you have only one parenthesis instead of two. So if you go back, press the program button, go to edit. Yes. Okay. Okay. 1, -9, -22. Bizarre. Okay, let me look again. Oh, I see. You wrote pluses here instead of times.
Oh my god.
There you go.
Thank you.
Let's double check real quick. Yep, that was all it was. You're welcome. Yes. Okay, so all the issue is for you is if we look at this, the second one's supposed to be a subtraction symbol there. So that should be it. And then if we do that again, there we go. Good. Why don't you guys try 2? Try to do 2. It just might, I think the different operating system gives you, like it displays a little bit different stuff. The done doesn't matter. Yep. After you type in your value for C, just press enter and it should spit it out automatically. Depending on the directions. You can always check it with the calculator. For 2, what did we type in for A, B, and C? B is 0 on number 2, yes. You just got to go all the way through the program, type in the wrong answer, just start over. So you can't go back in the program. We didn't write that sophisticated of a program. You get one shot at answering A, B, and C correctly. If you type in the wrong number, you just got to type in some more wrong numbers and just start over. Did you guys get that for B now? Okay. How about for 3? What do we have to do for 3? Yeah, you got to set it to 0 first. everyone get -3, -4 for 3? Good. Try 8. Do 8. So you should have got, most of us probably got an error when we tried to do 8. What did your error say? Non-real result or non-real answer. Why is that? Doesn't matter if it's not factorable. The quadratic formula can handle it. Let's see what happens when we try to do this by hand. There's a good story at the end of this, I promise. Go away. Okay. So if I plug this into the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. So I get 3 plus or minus 9 minus 160 divided by 8. 9 minus 160 is negative 151 over 8. And what happens when I try to take the square root of a negative number? I cannot take the square root of a negative number. Why not? Because there isn't something that I can square to give me negative 151, because I can't take two identical numbers and multiply them and get a negative. If they're both negative, I should get a positive. If they're both positive, I should get a positive. I can't have two identical numbers multiplying to give myself a negative, right? So we don't have a way to solve this particular problem. So what do we do in mathematics when we don't have a number that we need to be able to solve a problem like this? We create one. We extend our set of numbers so that we are able to answer questions like this. And now I say that, and you're probably thinking, Mr. Kulik, that's a load of baloney. You can't just make up new numbers because you can't do a kind of a problem. And I would say, you've done this at least 4 times already in your mathematics lives. Let me take you on a tour of extending your number set so you can do problems. Back in elementary school, what were the first set of numbers that you learned? 1, 2, 3, 4, the counting numbers. After you learned how to count, the first thing you did in math after that was starting to add, right? And if you add 2 counting numbers, everything goes along swimmingly. After you learn adding, what do you learn? Subtracting. What's the problem there? If I do 5 minus 7, I get a negative number. We didn't have negative numbers prior to that point. What did we do? We create negative numbers so that we're able to solve this kind of a subtraction problem. So now we have positive and negative numbers, and everything is fine for a while. The next thing a little bit later on in elementary school you start talking about is multiplying. You multiply 2 numbers together, negative or positive, doesn't matter. Everything goes along swimmingly. What do you do after you multiply? Start dividing. If you do 5 divided by 7, what's going to happen? You get a fraction or a decimal. We needed to extend our number set again to include answers to this division problem. So now we have positive numbers, we have negative numbers, we have fractions, and we have negative fractions. Right? And everything is fine. We introduce things like square roots. We have a number like the square root of 2 that you cannot write as a fraction. what do? Well, we extend our set of numbers to include these decimals that we can't represent as fractions. Those kind of numbers we called irrational numbers. So when we take our positive and negative whole numbers, our positive and negative fractions, our positive and negative irrational numbers, all together we call that set of numbers the real numbers, and that's what we've been using for several years now. That is now going to change because we're going to extend our set of numbers again so that we can answer questions like this. This new set of numbers is called the complex numbers. And to do that, we need to define a special number called the imaginary number. And we represent that imaginary number with the letter I, and we define I to be the square root of -1. As an immediate consequence of that, what does I squared then have to equal? -1, right? If I square both sides, the squared cancels the square root, and I'm left with I squared is -1. Is everybody okay with that idea? So, we're going to take that special imaginary number, and we're going to create a new set of numbers. So the symbol we're going to use for that set of numbers is this special looking C. That C stands for the complex numbers. So the complex numbers is a set of numbers, and the numbers inside the complex numbers look like this. I'll explain what all these symbols mean in just one second. I just want to give people a chance to write things down before I start talking, because it's hard to write and listen at the same time. So when we write these squiggly brackets, what does this mean? It's a set, right? This part at the beginning tells me what the things in this set look like. Now you might ask yourself, okay, what the heck are A and B? Well, here I tell you, A and B, this symbol here, this like curvy looking E, is a symbol that means members of. And this R with the double bar on it is the name for the set of real numbers. So what do these complex numbers kind of look like? Let's look at some examples. How about if I write 3 plus 5i? Is that a complex number? Yeah, right? The 3 is like my A, the 5 is like my B, and then I have my I. Everybody okay with that idea? So we have names for these parts. The A we call the real part. The BI we call the imaginary part. So a complex number has two parts. It has a real part, the part without the I, and the imaginary part, the part with the I. Let's do another example about deciding whether this is a complex number or not. Is this a complex number? Yes. I can think about this as 7 plus negative 1i, right? Now it's definitely in that form. What about 3i? Is that a complex number? Yep. Wait a minute, where's the a part? Oh, the a is just 0. Oh, Mr. Kulik, you're so sneaky. What about 12? Is that a complex number? Yup, it is. Wait a minute. That doesn't have the bi part. Sure it does. The b is just 0. Oh. So what are we saying here? Everything is a complex number. Whoa! Okay, so we have this new set of numbers. We need this new set of numbers because we have these kinds of problems that involve taking the square root of a negative number that we weren't able to solve before, that we can now be able to find an answer using this technique or using this kind of number set. But before we go back to that problem, we should probably talk about just how we manipulate complex numbers, like how do we add them, subtract them, multiply, divide them, just so that we have a clear picture of what's going on. Everybody okay with that? So let's say we're adding the two complex numbers, 3 plus 2i plus 5 minus 3i. How would you hope that the addition here would work? Under best case scenario, if you were to pick how the addition was going to work, how would you want it to work? Because we have to define how this works, right? When we created fractions, we had a very special way that we had to add them together that wasn't very easy. I don't want to FOIL this. We're not multiplying. What did I do here? I combined like terms. That's all we're doing. Best case scenario. Works exactly as hopefully you would hope it would work, right? So just 3 plus 5, 2i minus 3i. What if we wanted to do a subtraction problem? Well, what you remember is the definition for subtraction. We've used this before recently. I can rewrite subtraction as adding a negative, right? So I can rewrite it this way. When I have a negative sign in front of a parenthesis, what do I have to do? I distribute that negative into the parenthesis. And then I can just combine like terms, because it's an addition problem now. That's pretty good news as well, right? What if I have a multiplication problem that looks like this? What would we hope we do to here? Just distribute, right? That's exactly what we're going to do. So that gives me 15I minus 9I squared. But remember, what is I squared the same as? Negative 1. So really, what does this become? It becomes 15I plus 9. Or really, we'd like to write it as 9 plus 15I. Everybody okay there? What if I have this multiplication example? How would you hope to do this? Now we're going to FOIL. So first gives us 10. Outer minus 4I. Inner plus 15I. And last, negative 6I squared. So I can combine like terms. And I remember, what is I squared? That's really just negative 1. And then if I combine like terms again, I get 16 plus 11I. Of course. Are we okay there? So addition, subtraction, multiplication, all been very much as expected, right? Slightly more complicated than dealing with just regular old real numbers, but not unexpected, right? This is kind of how we would hope this would work. That kind of ends with division here. So we'll do a couple of different ones, because there's a couple of different situations. So what if I want to divide a complex number by just a regular old real number? Well, I know division is distributive, so I can do that. And just divide both pieces by 2. 4 divided by 2 is just 2. And then 3 over 2 is a real number, so I can just write that as 3 over 2 times I. Oh, I thought you said this was going to be bad. That wasn't so bad. Let's look at another example. Not yet, although it gets a little worse here. So I need to do the same thing. So I notice on this fraction, the 4 and the 2 can reduce. And on the second fraction, the i's can reduce. So then I'd have 2 over I plus 3 over 2. Is this, though, written as a complex number? No. What's the problem? The I is in the denominator of my fraction. So what I'm going to do is I need to get that I out from the denominator of my fraction. I'm going to accomplish that by multiplying the top and bottom by I. Now if I multiply by I over I, what am I really just multiplying by? 1, which doesn't do anything, so I'm free to do this. When I multiply 2 and I get 2I. When I multiply I times I get I squared. And what is I squared? It's just negative 1. And that just simply turns into negative 2I plus 3 over 2. This piece right here has a special name. We say that that's multiplying by a conjugate. when we do that to get the I out from the denominator. And when the I is a purely imaginary piece, it's not so bad because you just need to multiply by I over I, and it kind of takes care of it. Here's where it gets bad. Is when I take one fully complex number and divide it by another fully complex number. So I'm going to start by writing that as a fraction. And now what do I need to multiply the top and bottom of this by to get the I out from the denominator? Not negative I. This is tricky. It's not at all obvious. It's going to be 5 plus 3i. So it's the same thing as whatever's in your denominator, just with the opposite sign between them. These are also called conjugates. Yes, Alyssa? Of course. So to multiply this out, what are we going to have to do? You have to FOIL the numerator and denominator. This is where it gets a little bad. So that's going to give me 15 plus 9i plus 10i plus 6i squared. And in the denominator, I'm going to have 25 plus 15i minus 15i minus 9i squared. If I look in the denominator, I see something nice happening. Notice that I have a plus 15i and a minus 15i, right? So those will add to give me 0. And I know that I squared is really the same thing as negative 1. So now if I combine like terms, I have 15 plus a negative 6. That gives me 9. I have 9i plus 10i, which gives me 19i. And then I have 25 minus a negative 9, which is the same thing as 34. And then to make this a complex number, I'll just write it as 9 over 34 plus 19 over 34i. That's as bad as it gets. It's just having to do that double FOIL and then resort everything out. When you do this, though, during division, when you end up with your denominator, it should always just end up being a single real number, like 34 or 26 or 19 or whatever. It's going to just be a single integer value, which is really nice. Whenever you multiply a complex number by its conjugate, you get a single real number like that. All right. Now that we feel a bit more comfortable with real numbers, which you should, right? We've defined what they are. We've talked about what is or what isn't a real number. We've talked about how to add, subtract, multiply, and divide them. Let's go back to this problem at the very beginning. That was our motivation to kind of get started on this whole long track to begin with, which was here. So, how do I finish this problem now? I know that the square root of 151, or negative 151, is the same thing as the square root of 51 times negative 1. Actually, I'm going to write it in the other order. It'll make more sense. And I know the square root of negative 1 is just I. I can rewrite this as 3 plus or minus I square root 151 all over 8. And that's how I'll represent my answer here. We did all of that just to talk about, I can replace the negative side under my square root with an I outside of my square root. That's the summary of what we just got done saying there. All right, I'm going to stop here.